Hello everybody. This is Professor West, and in this segment I'm going to be talking about something we call expressions. And I'm doing this to help some of my students who might be having some questions about expressions, but I'm posting it for everybody in case any of you would like to know. So, first things first, what is an expression? Very simply put, whenever we have a variable and we assign it a value, we have, in this case here, I have x equals 5. Everything on the left of the equal sign is a single variable. Then there's the equal sign. Everything after that is an expression. So, in this case, the number 5 is an expression. It's the expression that I'm assigning to x. If you look down just a little further, this might look familiar. You might have seen this in junior high, where it says y equals x plus 3. Well, in this case, we would substitute 5 for x, so the answer would be y equals 5 plus 3, which would be 8. So, technically, this would be an expression, but the answer would be 8. So, that's all we're talking about with expressions, guys. We can... So let's look at some different expressions. If you come down just a little further in this book, you'll see here's some questions. Type the expression that appears in the given statement. Ounce per gallon, that's our variable, just like x was our variable in my example. There's our equal sign, so what did I say the expression would be? Everything after that. So, 128. Let's test it. Ta-da! Same thing here. Destination equals my address. So therefore, my underscore address would have to be the expression, right? There you go. Everything after. Now here, it gets a little different. We have inventory count equals num rugs plus num pillows minus 1. Now we don't know the value of num rugs or num pillows, which means this is our expression. Instead of typing the whole thing, I'm just going to click the show answer, and there you go. That's the answer. The whole thing, all of this to the right of this equal sign, is the expression. And we got one more here. Student average, class A plus class B divided by 2. Again, we don't know what those are, so the whole thing is the expression. That's it, guys, as far as what an expression is. Now, how we use expressions gets pretty interesting. We have a couple terms here. An operator is a symbol for a built-in language calculation, like the plus sign. So these are arithmetic operators, and we use them in our expressions. Like you see here, we had in parentheses class A plus class B, and then outside the parentheses divided by 2. So let's talk about some of these real quick, because a couple of them might be new to you. There's the plus and the minus, which I'm sure we've all done addition and subtraction. There's multiplication, and there's division, which we've all done that as well. This one is called floored division. Let me show you how floored division works. First, let me show you how division works. So, let's say num equals 5, or let's say 10 divided by 2. So what would the answer be? The answer would be 5. Now let's say num equals 10 divided by 3. What would the answer be? The answer would be, there's two ways we could do it. We could either go with decimals, or we could go with 3 with a remainder of 1. Remember when we used to do that in math class? 8th grade? So 3 goes into 10 3 times. That makes 3 times 3 is 9, with a remainder of 1. If we use the floored expression, we are telling the computer to ignore the remainder. So in this case, 10 divided by 3, if we used the floor sign, 10 divided by 3, then it would be, the answer would be 3 without a remainder because we drop the remainder, also known as rounding down. So if I had used it here, it would not have changed anything. 10 divided by 2 is 5. So it would have not mattered one bit. But if there's a remainder, if you use the floor command, which is 2 slashes, it drops the remainder. This next one here is called Modulo. We call it mod for short. So, what does that mean? Num 10 mod 3. What did we say the answer would be a minute ago? I said it would be 3 with a remainder of 1. Well, when you're dealing with mods, it does the exact opposite of floored. It drops the first number, and it only cares about the remainder. So 10 mod 3, the answer is 1, because that's the remainder. This is used when you want to know if a number evenly divides into something. For example, 3 obviously does not evenly divide into 10. So, and then there's exponent. Exponents are very simply put. If we said 2, we usually use this symbol to the third power, but in programming with Python, we're going to use 2 asterisks instead. Now, in math books, you're going to see it written this way. You may even see it written this way in our textbook. I'm not sure. But as far as programming is concerned, we do it this way. These two mean the exact same thing, only Python will understand this one. It won't understand this one. So, what does that mean? What does exponent mean? This means 2 to the third power. You've probably seen 2 squared. If I was just writing it on a pencil and a paper, I would write a 2 with a smaller 2 above it. And that would mean 2 squared, which would mean 2 times 2. That's also 2 to the second power. This is 2 to the third power, which means you simply do it one more time till there's 3. If I would have said 2 to the 6th power, then that would have been 2 times 2 times 2 times 2 times 2 times 2. 6 times. 2 times itself. This number times itself 6 times. So 2 times 2 is 4 times 2 is 8. So 2 to the third is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. So 2 to the 6th would be 64. And you could do that with any number. I could do 5. 5 to the 6th and 5 to the 3rd, whatever. 5 to the 3rd would be 5 times 5 times 5, which would be 5 times 5 is 25, times 5 is 125. And, you can go on. It doesn't matter what the numbers are, but just know that it's this first number times itself this many times. That's what an exponent is. Now, it's important that you understand these symbols, so play around with them and practice a little bit if you need to, because that's going to come in very handy when we start actually doing more complex expressions. Like we have this one here, down payment plus, open parentheses, monthly payment, times number of months, close parentheses. How do you solve something like this? And solving it means getting the answer. That's all solving it means. So, how do you solve it? In order to solve it, we're going to have to know which one to do first, which I will get to in just a minute. For now, I want to come down here and show you some other expressions behavior. So these questions are asking which ones are correct and which ones are not. Excuse me. 6 plus num items. Is this correct? It looks correct. I'm going to say yes. And it is. It's straightforward addition. 6 plus num items. If num items was 10, then the answer would be 16. 6 times num items. Is this correct? It looks correct. That's how you would have written it in 8th grade. But in the programming world, remember, we don't use the letter X. We use the asterisk. So, this would actually be 6 asterisk num items. Because we don't use x for a times sign in computer programming. X is just a letter. So, is this correct? I'm going to say no. That's true. And it tells you the asterisk is not an x. Total days divided by 12. Is that legitimate? Yes, it is. Straightforward division. 5 times I. Is that going to work? Again, in high school, when we did 5i, that would work. But here, we would have to have 5 star or asterisk I, because that's the multiplication sign. Omitting the asterisk is not allowed. It has to be like this, 5 times I. The negative of user value. Is this legitimate? Think about that for a second. Can I say negative user value? Absolutely. If I said, if that was 5, I could say negative 5. That's total fine. Yeah, we call it negation when you change a positive to a negative. Item A plus item B divided by 2. Is this okay? Now, this is a little tricky because technically this would, and we'll get to this when we get to the order of operations. They actually should have explained that before they gave you this one, because that makes this one a little tricky. In the order of operations, we do multiplication and division before we do addition. So this would actually be item B divided by 2, and then we would add A. The way it's written here with a comma tells me that they wanted us to do this part first, which means that it would not work. So let's see if I'm right. Yep. I wasn't sure because I've never used this textbook before. Wasn't entirely sure if that's what they meant when they did it like that, but it was. In order to do item A plus item B first, we would have to put those in parentheses, which we'll get to in just a second. And in factorial, can you write it as in factorial? Absolutely not. Let me explain what in factorial means. In high school, we would have said 6i to represent 6 factorial. Here, in programming, you cannot. 6 factorial means 6 times, and you just keep going down till you get to 1. 5 times 4 times 3 times 2 times 1. So, 6 factorial would be 6 times 5, which is 30, times 4, which is 120, times 3, which is 360, times 2, which would be, 720, times 1, which would still be 720. So 6 factorial would evaluate to be 720. But you cannot write it like this, because that's not a programming answer. There's not one for programming. Although, at some point we will get to something called recursion, which will allow us to make our own. But that's a whole nother thing for another time. So, anyway, moving on. Now we're going to actually have some of our expressions. And here's what they're telling you here with this little tip. This is a good practice tip. They're telling you that when you write these expressions, it's a good idea to put a space between them, kind of like I did here. I put 6 space times space 5. They like for you to have that. Now the only difference is, let me change it up. Let's say plus. Let's say 5 plus 6 plus 3. Okay, if I wanted to write this one, I would actually want to write it like that. If I wanted to subtract 5 first, though, I would not do it like this. I would not say negative and then a space and then a 5, because I'm not subtracting 5 from anything. Now, I could say 0 minus 5 if I wanted, but that's more trouble. So what you do is, you don't put the space here. This tells the computer that this is not minus 5, it's negative 5. And so negative 5 plus 6 would be 1, just as if I would have said 6 minus 5. But if you're wanting to do it as a negative number, you don't put a space here. You leave those right beside each other. And when we do this, we call that a urinary operator. I'm not going to worry about doing all these, retype each of these statements, because I want to get down to this last part real quick. You can do those on your own. Basically, it's the same thing we've just been doing. But anyway, here we go. Now they're actually going to show us some of what I was showing you a while ago. With division, 20 divided by 10 is 2.0. Anytime, I was using whole numbers a while ago, and I apologize for that. Anytime you do division, it comes out as a decimal place. Even if it's 0.0, it's still 2.0. It's still a decimal place, which means that this has to be a float variable, not an integer. And in this case, 50 divided by 50 is 1. 5 divided by 10 is 0.5, 0.5. If you come down and do the floor, remember what I was telling you before? It just drops the remainder. So 20 divided by 10 is 2, nothing happened. 50 divided by 50 is 1, nothing happened. 5 divided by 10 was 0.5, but we dropped the 0.5 for the remainder, and it's just 0. 5 divided by 2 is 2. Even though there's 1 left over, we drop the remainder. And then here we are using modulus. 23 mod 10. 10 goes into 23 with a remainder of 3. I'm sorry, 2 times. 10 goes into 23 2 times, which would be 20, with a remainder of 3. But remember, mod drops the first part, so all we have is the remainder, so the answer would be 3. 50 goes into 50 0 times, with the remainder of 0, so the answer would be 0. 100 goes into 5 0 times, with a remainder of 5, so the answer would be 5. So, anyway, and now we can get into some of this other stuff. They're going to have you play around with some of that a little bit, and you're welcome to do so on your own time. This is my time. Okay, here's the other thing I wanted to mention as far as expressions is concerned, and that's the precedence rules, or the order of operations as we learned them in high school. In a mathematical equation, like let's take this one here, 2 times a plus 1, you do whatever is in the quote or in the parentheses first. So I would do whatever's in these parentheses first. A plus 1. It says here that a is 1, so 1 plus 1 is 2. Now, this basically would then be replaced by 2, and we would have 2 times 2. So that would end up with the result being multiplied by 2, which would be 4. The next thing you do is exponents. 2 to the third power, 2 times 2 times 2, which would be 8, plus 1, which would be 9. So the first thing you do, if this would have been inside these parentheses here, then we would have evaluated the parentheses first, which means inside the parentheses, we would have looked for the first thing to do, and the first thing to do would have been this, unless there was another set of parentheses in there. But the second thing you do after parentheses is exponents. The thing after that would be any multiplication or division, and that includes the floor and the mod, followed by plus or minus, and lastly, moving from left to right. So, if you have 5 plus 3 plus 2 minus 1, you would just literally start at left and say 5 plus 3 is 8, plus 2 is 10, minus 1 is 9. And that's the same for all these. If you had 5 times 3 minus, or divided by 2, you would literally do the 5 times 3 first, and then divide that by 2, unless you have it in parentheses or something. So here are some examples. Bill plus 0.15 times the bill. That would, if let's say your bill was $100, then that would be 15 plus 100, which would be 115 plus the bill. Or actually, sorry, this part here would figure out that it's 15, and then we would add it to the bill, which would make it 115. My bad. Number of cans, 3,500 divided by cal per can, you would simply swap that for whatever the number is and do the division. And so forth. And then there's some participation activities for you to do, and a challenge activity. But as far as expressions are concerned, guys, that's just about it. As long as you remember, you do what's in parentheses, then you do the exponents, then you do the multiplication and division, and the other parts of that, addition and subtraction, and finally left to right. So I hope this has been helpful to some of you. If you have any questions, make sure to let me know, because I'm always here to help. So whether you're one of my students or not, just let me know if you got a question. And I will see you guys in class.